Bismillahirrahmanirrahim. Welcome to Diode and Application Season 2, brought to you by, of course, Learn. But first of all, let's take a look at today's topic. These are the topics we had decided to in today's episode. Some further applications of the LED, continued topic from the last episode. Just very precisely, which very shortly we will discuss some further applications of the light emitting diodes, and then the organic LED. Very interesting and very interesting topic, and that is the focus. We will focus and very important emerging technology, OLED. Of maybe sometime you listen this word in news or etc. in technology. So we will discuss OLED, a type of the diodes, and applications of the OLED. We will focus LEDs further application, and at the end, as we discussed early in previous episodes, some benefits. This is the further applications of the light emitting diodes. Most of the times you see these type like this is a example of open and close. Sometimes in the shops you may be seeing some types of signboards. Maybe sometimes they also write their names in the combination of the LEDs, like here. This looks like more interesting when it is written in this form. So this is a use, and further for use another pattern they can also used in an LED message boards. And these message boards are used as a screen, a poor way of screen they can manage in a cheaper way, and by it is made up of combination of many LEDs in a specified pattern, and they are managed with a processor unit. In this in the casing there is a board, and we can display a message animations as well on this. And most of the time this is used in the larger shops or maybe some organizations. And for example, if you go on for example railway station, these type of the message boards were used earlier, but nowadays these are also replaced. Okay. This is a LED in a liquid crystal display screens, widely used in the large screen television. The basic colors RBG, red, blue, green, are used. This is the basic colors. You can see that this is the red, blue and green. The combination of these colors, a million of these combinations form subpixels, and by the changing their currents, we will also discuss in the next slide. But here you can see that this is a LCD liquid crystal display, and it consists of thousands of RBG pixels, as I was talking in the previous slide. RBG primary colors are there, the three primary colors. This is the red, blue and green, but these are basic colors, basic pixel. But some manufacturers added yellow colors too, because we can for example, if we had only two combinations, let's say red and green, how many combinations we can achieve by varying their intensity? They are less, of course. If we add blue and in this, and we have three colors, we can manage more combinations. So some manufacturers also added yellow to achieve better resolutions, to achieve more colors combinations. So that's a way of achieving more combinations. So light emission can be varied by varying individual IF. What is the meaning of this? I had written in these slides. This means that there are three diodes are to make a pixel. Light emitting diodes are connected in such a way that their cathode is a common, that is grounded, but they are connected in parallel. Okay, in parallel circuits we had discussed that the current remains this current divides, but voltage remains the same. So the same voltage here, 5 volt for example, same voltage is delivered among them, but the current is different. We can adjust the current, forward current, because they operate in the forward bias. For example, I reduce the forward current of red. It means that if this is less, then this pixel may have a different color. This is a pixel, we cannot even see this pixel. This is a very small in the screen. A screen contains million of pixels. Okay, so A normal LCD of a computer, let's say, contain million of pixels, but inside this there are three colors, and in how what is the terminology of the three colors is this is the circuit diagram. Okay, so this is the way how we can change the individual current of these pixels, and this is an example we are talking about. This is the red, green and blue colors, and if we on all the colors with the same current, same ratio, a white is achieved. And if we turn off the blue green color, red and blue are on, and we are achieving the magenta color. This is the same, some other examples are given in the same combination patterns. And this is another application. Light intensity LEDs are used nowadays in headlights and in tail lights. You can see that LEDs are used. They have two main benefits in the next slide. Yes, visibility is much better in poor weather, foggy weather for examples. They have much more visibility than normal bulbs, incandescent bulbs, and lasts up to 100 times than the bulbs. So they are used, they are preferred in the as they are more efficient as well. Okay, home purpose, they are also used. LEDs are also used in the form of these shapes are nowadays they are used because they are much more efficient as well, and their life is much better than the previous. Okay, this is the important topic and basic topic of today, OLED. Basically this is an organic LED called OLED. Technology was first developed by the Eastman Kodak company. This is a company, and in 1987, maybe you after hearing 1987 you think that I was saying this is a new technology, but here it's 1987, it's invention, but this is a just invention. Okay, developed by the 1987, but this was not released in 1987, but works start on 1987. It is the beginning to replace the liquid crystal display LCD technology in handheld devices such as PDAs and cellular smartphones. We had decided, for example, in previous cases, you know that the smartphones when came, they are much thicker in size as their batteries, casings, and LCDs also occupy more space, but nowadays their functions are increased, but their size is reduced and they are slim, very slim. So we in cellular phones, smartphones, we always try to focus to reduce size. Every aspect is noted. So batteries, we always try to reduce the size of the battery. We always try to slim down the components of the board, and we always try to reduce the size of the LED. So organic LED, by achieving the organic LED, this is a way we can reduce and even slim our mobile phones. Okay, OLED are brighter, very brighter. This is also benefit, thinner, faster and lighter than the conventional LCD or LEDs. They are also use low power and cheaper to manufacture. This is the way you can so this is the future of the technology. In 2009, Philips became the first company to manufacture. So after how many years, you can imagine, 1987, and the first product came in 2009 and by the Philips, that is called the Lumiblade, and just 2 millimeter thin. And in 2013 later, Philips and BASF are combining efforts to invent a lighted transparent car roof. The car roof will be solar powered and will turn transparent when the switched off. This is the switch off state and it's transparent. We can see the face, and this is the intermediate state, and some blurry image can be seen, but this is the pure on when it's 100% on. And in this state it is not transparent, it provides us light, and the light is emitted in the both directions, in the towards other side, back side, and towards us as well. So both sides, and it's transparent as well. This is the first camera screen that is developed by the company called Kodak. This company is same as I showed on the previous slide. It invented this company they invented the organic LED technology, and they also made the first or LCD display, OLED display, that is 2.2 inch wide and very thin display, 512 by 218 pixels. This is the ratio that is used, and an OLED is a device that consists of 2 or 3 layers. This is the construction and internal diagram. We are going to focus 2 or 3 layers, depends upon our construction materials, but mostly 2 are used. Okay, material composed of organic molecules or polymers. 2 types of materials can be used: number 1 organic, and number 2 polymers molecules. You can see that from this image they can also be folded. Very interesting this technology, because we can also fold. Even you can imagine this, we can fold. Even there can also be packed and packed in the encaded. If this technology is released, we can also pack our mobile phones, tablets in a light in our pockets. For example, a large screen can be packed, and we also have no fear that our LCD will maybe damaged. But okay, this is a very important slide, and this is the construction or working principle. And this process, the whole process is called electrophosphorescence. And you can see that on the top there are cathode, and cathode is made up of usually a transparent material. And this first layer is, and there are 2 layers basically between anode and cathode. There are not p and n junctions, there are 2 layers. This is the cathode and this is the anode. As indicated, this is a positive and this is the negative. Between these two there are the conductive layer and an emissive layer. The topper layer, the green, this is a zoom image. The green one layer towards the cathode sides, is called emissive layer, while the below layer, that is orange color, is called conductive layer. Okay, so in the towards cathode, when we connect this towards the bias source in the forward bias direction, negative is connected with cathode and positive toward the anode. So electrons are coming toward from the negative side. So always when there are electron at the cathode, always attracted by the positive, that is opposite polarity. So negative tries to enter into the emissive layer, and the you can see that the electrons are entering in the emissive layer, and then these electrons are moved towards the conductive layer, while the already present electrons in the conductive layer will leave. And when they leave, for some instance there are some holes. So vacancy available, we can say that these are the holes, and holes carry positive charge with this. Although holes carry no charge in real, but with respect to negative charge, we can say that this is the positive charge. Okay, when these are the holes and act as a positive charge in this layer right now. But this process continues when these electrons wants to further pushed by this biasing source, external bias source. These electrons are further tries to do the same process. When these electrons enter into the conductive layer, and these holes will release energy, these holes will try to go in the emissive layer, because these electrons will replace their place, and these will replace their place of the electrons. So when these holes move towards the electron side, because they are at higher potential right now, so they will leave energy in the form of photons, and the photons are lights. So light will be emitted towards this side, upper side. I will also show you in the next slide, but this is another diagram for further clarification. This is cathode and this is anode. There are the 2 layers can be made of the organic molecules or polymer, and conductive layer can also be of the organic molecule or polymer. This is the substrate. Light is emitted towards this side because cathode is made up of the transparent material, but if we can also made the anode or substrate as well as from the you can say that transparent material, then the light can be emitted from the both direction, as you can see that in 2013 in application is found in the cars. In the previous slides I showed you. So this is the way how it can works. The light is emitted on the top side, but if this is made from the transparent material, this light can be emitted in the both direction, and the when the external source is cut off, it looks like a transparent material. This is the working principle of the organic LED. Very simple process. Once again I showed you in a different form. Maybe it looks like and maybe some students found any form easier, and always try to taught you in a easier try to taught you on a easier steps, and that's why I added more diagrams in my presentation. The color of the LED depends light depends upon the type of the organic molecule in the emissive layer. Okay, this is the emissive layer, and this depends because the hole will leave from this layer, so that's why the energy is released in this when the hole move from conductive layer to emissive layer, and this light will start from glowing from this. If this, for example, have a organic molecule that emits red color, then the LED the light will be red. And if this, so this depends upon the emissive layer. And this is once again the same things I already explained, that this process is explained step by step. You can read by yourself, and I write it because I will provide you at the end this presentation in the description. It's available, so you can read by yourself. This is called heads up display. In this display, the both we can see from the both directions. If this is a mobile phone, we can, it's easier to understand, but if you can imagine if this is the technology used in the mobile phone screens, we can see you can see that 20 km/h in this diagram, let's say. So you can imagine that by driving it's easier to understand. Only the arrows and the written things are displayed, but everything is transparent. Screen is transparent in this case. This is the imaginations display, and will be released soon, and maybe when you are listening this video, these displays are released. These are some heads up displays, and this is the very thin example of the Samsung mobile, and this is already available in the market, and maybe some testing purpose. Further applications of this type of application will be available for you. And organic LEDs can be separated onto substrate just like the inks are separated onto the paper during printing. So you can imagine this is how slim and foldable technology, and better resolution as well, refresh rate, etc. Okay, so this is the type of the screens we can achieve. 80-inch TV screens or the electronic billboards and applications, and this is the application students might find useful. So that's why for refreshing of the whole lecture I added in funny, you can say that helpful material for the students, but just for the sake of interesting information, we can add the screen here. But when the teacher came while in exams, you can turn off, and it looks like a cheating material. But this is a application, that's why I discuss here, nothing else. Anyway, okay, OLED benefits: improved image quality, better contrast and higher brightness, fuller viewing angle. What is mean by fuller viewing angle? Look at, please come back here. Okay, if we watch this video from the front side, if we sit here and watch the video from the front side, we it's clear display, everything is bright, everything looks like clear, 100% okay. But if we are sitting here, if a person is sitting here, for example, this is a person watching from a different angle, not from the front angle but from a different angle, and it is not clear, some imaging, some image quality is not clear for this person. If person is sitting here, also not clear. So that this is a previous technology, but this technology, it's a fuller viewing angle, even not from some side angles but even from the previous side. both sides, full 360-degree viewing angle, a wider color range, as well as refresh rates are also better, lower power consumption, and ultra thin and flexible foldable and transparent displays, and better durability. This is the end of this lecture, and we will also in the next lecture we will discuss quantum dots in the same pattern on the computer. So quantum dots are also very interesting, and we will discuss on the next lecture. So this is end of the today's lecture. Hopefully you understand this lecture, but found this lecture helpful. Watch, learn, grow. See you next.